So the next 40 minutes, we'll talk about the brief history of scaling, what are the current architectures for scaling, then we'll look at the different workloads, and also I'll then introduce to the multi-dimensional scaling. I will basically go through all this very quickly, so that because you might have already read about it, or even have heard about this in other presentations, but I'll try to spend most of the time on the live demo. You can stop me in between and ask questions, but I would, since the session itself is 40 minutes, I would prefer taking the questions in the end. So here is that. So before we start on explaining what are the different scaling architectures we have, I would like to talk about different aspects of the database. So there are different aspects. The scalability is just one aspect of the database, right? So we have availability, we have performance, we have consistency. All of them work tightly coupled together, right? You can say, I picked this approach for scalability, but if there is no availability or if there is no performance, then it's not going to help you a lot, right? So basically, all of them has to work together, right? When you pick a scalability architecture, it has to be available, it has to be performant, it has to be consistent. All of the aspects has to work together. So with that in the mind, so we'll get started. So here is the one of the architecture. In this architecture, the ScaleUp architecture, it's not new, right? So this architecture has been dominant for 25 years, right? So basically the ScaleUp architecture, all of the components, right, all the resources are coupled together, right? They're all in the single monolithic server. If you want to scale your cluster, you basically add more CPU, you add more RAM, so you add more frames to the same monolithic server. So all of the way you add more capacity, the way you add more performance for this scale-up architecture is by adding more RAM, adding more CPU, so that you basically make it much more powerful, right? That's the way you scale up in this architecture. One good thing about this architecture, which I want to point out, is because all of these components are tightly coupled together, they're all in the same machine, right? So they're all together. All the communication happens over the memory, so which is the best part because it's very fast, right? So because your data, all the resources, everything is in the single monolithic server, you get a good performance there. So this architecture is good for many reasons, and I'll talk about the pros and cons. So here are some pros and cons of this. The pros is like, because one important thing I want to mention is because it's on a single monolithic server, all the communication is happening over the memory. There's no network dependency because there's no multiple nodes. There is no network dependency there, right? So that's why you can even get some major performance improvement because of the scale-up architecture, because since there is no network dependency. And also nowadays, you have much more powerful machines. You get a machine with 24-core processor, terabytes of RAM, right? So it's not uncommon. So if it was 10 years back, to get a 24-core machine, you'd have to pay a lot of money. Now it's not that much, right? It's basically, you can get a powerful machine easily. So those are like pros for this scale-up architecture. Now let's look at what are the cons for this, right? So basically, let's say you are building an application. We start to build an application. You have a few thousand users in the beginning, but very soon you'll scale to 2 million users, for example. But even in that case, you have to start with some capital investment. You need to have some good machine to start with, right? Even if you're not using the whole cluster, I mean, if you're not using the machine, you still have to begin with that. So you have to have some capital investment early on. So that's going to be very expensive for you. So it's not on demand. So basically, if you want to add more capacity, you cannot do it without taking a downtime. So one aspect of scalability is you can add more capacity in this case, but you have to take a downtime, right? So the other aspects such as availability and performance will be impacted because of the scale-up architecture. And also, let's say you want to add more performance to your queries. You want to add more capacity for your data. Then and the same monolithic server, it doesn't have any more room to add more capacity. You don't have more room to add CPUs or RAM. So in that case, you need to basically take this whole server down, bring the entire new device, right? So the way you can do that is basically you have to take a downtime. Basically, you're upgrading your infrastructure, right? You're taking the whole server down, you're bringing the new server in, right? So that's the way that affects your availability. That affects your performance, right? So that's the ScaleUp architecture. So it's limited by scalability, elasticity, and also it affects your availability and performance. So now let's look at Scaleout architecture, which is much more modern architecture, and Couchbase Server and many other products in big data in NoSQL space use this Scaleout architecture as the scalability model. The reason we have picked the Scaleout architecture is because it works great for your data, right? You want to add more capacity, you add more nodes to your cluster, right? The Scaleout architecture is basically a cluster of servers put together, right? All the computation are provided by this group of servers. You need to add more capacity, it's on demand. You can add more servers quickly without affecting your availability, without affecting your performance, right? Another best part of the Scaleout architecture is it can linearly scale with your throughput. You add more capacity, your performance increases, right? So basically, you're adding more computation power to your cluster. So the whole idea of the Scaleout architecture is easy to scale, simple to scale, without affecting your availability, without affecting your performance. So now so one important thing to mention here, because this is a cluster of nodes, and nodes are spread across in your cluster, they have to communicate over the network, right? So when you add more nodes, when you basically remove some nodes, rebalance, a data movement has to happen. That data movement happens over the network. So there is a huge dependency on the network. So here are some of the pros and cons of the scale-out architecture. Mostly the pros, because the scale-out architecture is very simple and easy to scale. There's no single point of failure. And also, as you add more capacity, as you add more nodes, it basically linearly scales with your throughput. So which is why most of this NoSQL databases, big data solution, have implemented the scale-out architecture as their scalability model. The one con about this architecture, which is the scale-out architecture, is it doesn't fit well for all the workloads. And I'm going to talk about the workloads in a bit. But mainly the idea here is it works great for data workload, which is basically your core data operations, set, get, update, delete, all these business operations. And you need a sub-millisecond response time. You want to add more capacity on demand. All this is great for data workload. For the index workload or the query workload, you don't want your data to be scattered across multiple nodes. Because when you want to do a query, you don't want to send a request to multiple nodes, gather the data, do the computation, and send the result back. It's going to take a lot of time. It's going to add latency, performance impact, and that's why it doesn't fit well for the index and query workload. So the idea here is the scale-out architecture works great for data workload, but not for the index or query workload. So this is going to be fun. So which is the right model for you, right? Because now you know the pros and cons of scale-up architecture. Now you know the pros and cons of the scale-out architecture. So the question is, what is the right model for you? So this is not us only asking this question. There was a white paper which was published by folks from Microsoft Research in Cambridge, and they were asking the same question. Do we need to scale up or scale out for the Hadoop workload? And if I have a link up there. So basically, when you read this white paper, what they found out is not for all the workloads of Hadoop, the scale out is a good solution. What they found is scale up is for most of the workloads, the scale up architecture, in fact, gives a better performance and better it's cost effective also, right? So this is exactly what we were asking the question. Is like when we looked at our Couchbase server and we looked at all the workloads, we do all this sizing operation where we know if you want to create multiple indexes or you want to have cross data center replication and you want to run multiple queries, how much CPUs you need, right? How much of RAM you need. So that was the sizing exercise we did. And we always added more CPU for when you have more indexes. And you have more queries, we added more CPU. And when you have more workload for data, then we said we add more RAM, right? So depending on what workload, we kept all making more adjustment to your server, right? So basically, we were doing it like without knowing. We were doing the same thing in the same architecture, like scale up or scale out, right? So basically, the question is, for your workload, what do you want to choose? You want to choose the scale out or scale up, right? So I would like to go into the, before I go into the multi-dimensional scalability, I want to spend some time on the different workloads we have. Most commonly, all the databases have 3 workloads, which is core data processing, which is your all get, set, delete, update operations, which is core operation to your database, right? You want a sub-millisecond response time for your core data operations. Then we have indexing workload, depending on how many indexes you have created for your database. Any changes to your data or new data will make the index to update, right? So that's this is for your queries to run faster. So that's the indexing workload. Then we have the query workload, where you do a complex join operations between multiple databases. You basically do aggregate operation, grouping, like all the complex operations, right? This is for reporting and analytics. So that is another workload, right? All these workloads, depending on your application, you would be using all these workloads in your cluster, right? But one thing to watch here is like all these workloads have a different resource requirement. So one solution might not be the good solution for the one. For example, when you want to add more RAM, it might be good for data workload because you need more RAM for your active data set to be in memory so that you can do a much faster processing. But that might not be the case for query. Whereas query needs more CPU. It needs more horsepower so that it can run multiple concurrent queries at the same time, right? So basically, one solution is not applicable to all of them, right? And also, if you want to fine-tune, like I was mentioning about sizing exercise, right? So when we do the sizing, we know that what's your cost expectation, right? So if you want a sub-millisecond response time for your data, then we will say add more RAM, because you need to have more RAM for your server. But now when you add more indexes, then we'll say you need to have SSD-backed storage. Then, and if you have a lot of queries, like 500,000 queries per second, then you will say add more CPUs to your server, right? So if you want to fine-tune your latency and throughput for each of these workloads, you cannot do it independently, right? So you're constrained because all of these workloads are running on the same machines, right? So basically, all these workloads, I think I have a picture here. This is how exactly it looks like, right? You have a cluster of servers. All these workloads are distributed across all these nodes, right? So even though I have put them as a separate workloads, they are actually one workload in database right now. So the thing is, like when you have a cluster of nodes, all these workloads will get a slice of the server. So basically, the idea here is each node will get a slice of this workload. It's very simple to add. Basically, as I said, Scaleout architecture is very simple. You can add more nodes. It's great. But the problem here is like when you add a number node 9, let's say you want to add more capacity, right? You want to grow your cluster because you're getting more data. You add number node 9, right? Now you don't have, not only the data workload has to stretch, you have to stretch your query workload, you have to stretch your index workload also, right? Because they're all coupled together. They're tightly coupled together. So that's the bad part of it, because when you do a rebalance operation, there's a lot of data movement happening. There's it's a cost. It takes up a lot of resources. It affects your other workloads. Whereas index workload or query workload need not have to do anything, but they are affected with the data workload. Also, one another thing, which is, let's say as I mentioned about the indexing and query workload, right? Why they are not good fit for the Scaleout architecture. So for indexing or the query workload, you want the data to be co-located. It has to be in the same, like basically in the same neighborhood, right? Because when you want a faster query response time, you want the data to be together so that you can do much more complex operations, like aggregation operations, grouping operations, and then get the results back, right? So the Scaleout architecture doesn't very well fit for indexing and queries. So we know the problem. The problem is you want to fine-tune your workload. You want to scale them differently, right? So at this time, currently, no other database today has this ability to give you an option for separating these workloads or scaling them differently, right? And this is where I introduce the multi-dimension scaling. So the beauty of multi-dimension scaling is, so first let's ask a question. So basically the question is, what is multi-dimension scaling, right? So multi-dimension scaling is, it enables you to separate, isolates the workload, and scale them independently with different scalability model, right? That's really the awesome part of it. Is like it gives you ability to separate each of these workloads and isolate them so that they don't interfere with each other, and also give them ability to scale them independently, and with a different scalability model itself entirely, right? So no other database, as of now, can support this one. So this is what we came up with, right? So we started thinking about the multi-dimension scalability when we started thinking about how do we give the focus on the performance of only this indexing, performance of only the query, right? And we could not do that because they were all tightly coupled together, right? So the multi-dimension scaling is basically a modular architecture. What it does is separates out, right? So what we are doing here is we don't call them as workloads anymore. We call them as service, right? So each of these services are separated out into a separate zones within the same cluster. So here the same cluster, 8-node cluster, and now we have different zones for this cluster. So one zone is for query service, one zone is for index, and one is for the data service, right? So we have basically separated them into different zones. What is the good thing about these zones is basically now you can independently scale these zones. You can have independent scale zones. Each of these zones won't interfere in each other's workloads. So for example, if you come from a database background, like me, I used to work in Microsoft, spent many years on SQL Server. So you would have had one occasion where there was a long-running query, which was taking up a lot of your memory, your CPU, and it was affecting all the other workloads. Your insert update where operations were slowed down, right? You have to go to the production and kill that long-running query because it was taking up a lot of your CPU. So that won't happen here. The reason is like now because the query will be running on the query service nodes, and any effect to the query service won't slow down your data service. Let's say you have multiple indexes building concurrently, right? So that won't slow down your data service. Your core data operations will still continue to provide the same throughput, same performance, sub-millisecond response time because it's independent. It's running on a different machine entirely, right? So that's really the beauty of the multi-dimensional scaling. On top of that, you'll really appreciate this is not only that we have separate zones, which have independently, you can independently put them separately, but also you can independently scale them. So for example, you want to add more data node, you want to add more capacity for your data node. You don't have to add a very powerful machine. You can just throw in a commodity hardware, right? So you can see that we had a node number 9 for the data service, right? Now you want to add more computational power, like more horsepower for your indexes, because not only you have 3 indexes, now you have 10 indexes, right? So you want to add more CPUs to your index service, storage back with the SSDs, for example, or Fusion IO, much more expensive ones. You don't want to do that Fusion IO for all your nodes. You just want to do it for your index services, right? So you can basically scale up your index service. Similarly, for query service, you want to have much more horsepower because you want to run concurrently many thousands of operations per second, right? So then you can basically add more CPUs to your query service. You don't have to have the same RAM. You don't have to have the same storage for all your hardware. So that's really the awesome part of multi-dimensional scaling, right? So if you, oh yeah, go ahead. I'll take the question. Right.
One of the node gets failed. So what would happen? Will it automatically move to will take a mode of the index service, or how would it?
Okay, it's a good question. The question is like, what happens when one of the machine fails down in the query service or the index service, right? So currently the scale-out, when we talk about the failover, right, the availability part of it. So the index service, the data service has the auto failover capability, right? We are in the current version, in the 4.0, this is the first version where we release this multi-dimensional scaling. The way we achieve the failover for index service is you can create multiple copies of your data by specifying it, right? So when you create an index, you can say, I want to create index on this node. And if you want a failover fault tolerance, basically in case if this machine goes down, you can create the same index on another node also. Right? In case if this machine goes down, you can have a backup on the other node. We can start taking so you don't have to rebuild the whole index from the scratch. Right? So similarly for the query, you can have multiple query services running on different nodes. Right? In future, what we would do is like similar to what we have for data service. You will have an ability to create replicas on the multiple nodes. Right? For this current version, you have to do it manually by saying, I want to create this index on the node number 1 or node number 2 all together, right? So it basically goes and creates the same index on both nodes. So that's how we provide the fault tolerance. So now I'll get into the little bit of the service architecture. So this is the full cluster architecture overview, right? So you see, we have some 6-node cluster, 6 nodes in a cluster. All of these nodes have something in very common, which is cluster manager, managed cache, and storage, which is very common in all the nodes, right? So this cluster manager, as you all might know, if you have worked on Couchbase, cluster manager takes care of all the cluster level activities, like rebalance operation, failover operation, adding a node, removing node, health check. Everything is done by the cluster manager. The managed cache is the very important part, which is which provides you the in-memory capability. All the interaction between the client to the server is done by the managed cache, right? Storage engine is for the persistence, right? So all of these nodes have these 3 components same, right? Along with that, now we have the 3 other services, which is data service, index service, and query service, which is new in the 4.2. Before, it would have been, we called them as data manager. Now we separated them out as a data service, index, and query service. Each of these are separate. We can optionally enable or disable these services, right? In this architecture, right now, if you look at this architecture, your cluster, this is a homogeneous scale-out architecture, right? You can make them into different the scale-up or scale-out by enabling or disabling. So here is an example where on the first 2 nodes, I have just enabled the data service. On the other 2 nodes, I have enabled the index and then query, right? So basically now for these 2 nodes, I can scale out. For these other 2 nodes, we can scale up, right? So this is how we achieve the scale-out or scale-up architecture for each of these workloads. So now, any other question? Yeah.
So how does the client library create the cluster map for the whole setup? Or how does it get it?
So the same cluster manager is running on all the servers, right? The cluster map is needed only for the data service because you want to know where the data is, right? So we basically shard the data into multiple partitions, right? So we want to know where the data resides. So for the data service, you need to have a cluster map, right? For the index, we need to know where the indexes are created, which server it is created. And right now, all the indexes will be, when you create an index, it has to be on only one machine, right? So that's one of the limitations. So let's say you create an index for a particular bucket. That index will go to one particular machine, and we know exactly which index is on that machine. Similarly, query service is basically, it doesn't need to have any map, right? It goes to the index service to get the data from there, right? So this is how we manage. Basically, the cluster map, partition map is only for the data service. We have a map, basically configuration for index service. We don't need for the query service. And in the demo, I'm going to show, I will show you how basically this is managed. So any other questions? OK. So now I'll go to the live demo. Sorry. Actually, before I go there, I want to show you. So this is internals, how it works. So this is a single node of a Couchbase server. And as I said, we have cluster manager, managed cache, and storage engine. And this all 3 services. Let's say, imagine that all these 3 services are running on the same machine, right? You have created this index on the same machine. You're running the query service on the same machine, and you have the data on the same machine. So this is how basically the flow will happen. So the managed cache will get all the data first. It will be, and I talked about architectural changes in the beginning. One of the things which I mentioned about is the DCP, the database change protocol. The database change protocol was introduced in 3.0, which is like a bloodline for the whole system. All these downstream components are consumers of DCP, right? So basically, as soon as the memcached gets the data, it sends to the DCP. The DCP is a streaming protocol. It gets the data, it starts streaming the data to all the other downstream components. We have something called projector and router. This sends the data to the index services. If you have created index for a particular bucket, all the data will be routed through the projector and router. The projector and router is optimized in the sense we do deduplications. In case if there's a same key gets updated multiple times in a same fraction of a second, we don't want to send the same data to all the indexes. So we do all this optimization in the projector and router. And also another thing is, let's say index 1 and index 2 are dependent on the same data, right? So you don't want to duplicate the same data and send it to the index service. You send the one copy of the data and send to both the index 1 and the index 2. So those all optimizations are taken care by projector and router. And now there's a supervisor part, which is in the index service, which takes care of let's say you make a request for not stale equal to data, so stale equal to false, which is like, I want the current data. All of that is managed by supervisor. It knows exactly what was the timestamp this index is, what's the timestamp of this index, how much of lag time. It understands all those parts. So when you run a query and you say, I want the most up-to-date data for the last timestamp, that query will be sent to the supervisor through the query service, and that will pick the index. If the index is not up to date, it will build the index and then send the data to you, right? So this whole thing is managed by all the three services in the Couchbase Server. So I think I talked too much about all this stuff. I'll now show it in action. So, all right. So keeping that the Wi-Fi issue apart, so we have a cluster of many nodes I have set up already. So here in this case, I have 4 nodes of data service. I have 1 node for index and query, right? Let's say now I want to add more capacity, and I need to add more index services. So if I have access to my right scale, I can get a couple of more machines. Give me 1 second. Okay, so I have a bunch of machines I've already started. So let me pick one of the machine. Let's say here. So I pick this machine. I go to my cluster and say add server, bring this server as this IP address, and it'll say data. I will just pick it as index, right? And then when I hit add service, it will basically gets added as a pending rebalance. The rebalance actually, our UI is still not very extensive, so we stay at a rebalance, but it's actually not doing anything there. When you click on rebalance, it just quickly adds it to the cluster because it doesn't have any data there. So there's no data partitions on this node, right? It just has the index services running. So as soon as you add an index service, it gets added to the cluster. Let's say now if I make some changes to the, let me do a failover operation on one of the data node. Let's say I failover this node. Okay, so let's say I do a failover of this node. You have 2 options, graceful failover to make sure that you don't lose any data in flight. So let's say I failover this server. So you can see that only on the data nodes, there was some activity happening, right? Whereas on the index node, on the query node, there was no activity. So because there's no data partitions there, right? So if you, as I said in the beginning, when you do a rebalance operation, you're on the data node, it doesn't affect the workloads on the index node or the query node, right? I can bring it back, this node, to the cluster, do the rebalance operation, and again, the data nodes have some activity there because they need to do the data movement, whereas the index node and query node not touched. They're not. There's no interference between them, right? Let's say if I want to go and create an index now, right? Hopefully this UI. Okay, I have the script ready. So let me go into one of this machine. So let me bring up my, okay, and run some workload on this machine. Okay, so here, let's go back to the data bucket. If I look at the default bucket, so you see some activities happening on this one, right? So you see that there is a lot of, so there's a bunch of operations per second on the data nodes. So all this, when you click on all the servers, let's say if you have all the data servers, let's say if I pick a data server, in this case you see the same activity here, right? Alternatively, I can do one more thing, which is if I show by server, it will show you that all these data nodes here have the same workload running, right? But on the index node, on the query node, when I click on those nodes, let me go back and click on the index node. So there's no activity on this, right? So there's nothing interfering with this node. Now, if I go and create an index on the particular node, on the particular bucket, let me create an index. Let's say, all right. So, okay. So if sorry, give me 1 second. Okay. So CBQ is a new shell command we have introduced with the Nickel. With using CBQ, you can do all the you can run all the ad hoc queries, right? So here I will basically check what indexes I have already created. So let's say if I run this system information command, and let's say, so it will tell me how many what indexes I've created. I have no indexes created. Alternatively, you can also check on the UI if you have any indexes there. So in this page, you will see that there's no indexes created. So let me create an index for a particular bucket. Okay, so let me add the travel sample bucket first. So this is a new sample bucket we have added in 4.0. There's also a sample app application, which is what was demoed in the keynote presentation yesterday. Everything is on the documentation. If you take a look at the getting started, you will get a hold of the travel sample bucket as well as the app. So while this is happening, so we have travel sample, the data is coming in. It shouldn't take much time. I will create an index on this travel sample bucket and also run some queries on that, right? So let's see if it is come back. Okay, should be done. Okay, so now I can create an index on this travel sample bucket using the global secondary indexes, which is the new architecture which I was talking about in the beginning. I hit create index, primary index on the travel sample. Now you go back to the our monitoring stats. Again, monitoring stats helps a lot to see what's happening on your cluster. So you take a look at the index service, not on this node, the other node, and you will see some activity here. For example, there was some activity on this node. Okay, so requests were made. Now let's go back and see if the indexes was created. Okay. So you see that a primary index was created on the travel sample bucket, right? So now let me run a query. Okay, so let me run this query. What this query is doing is basically it will, on the travel sample bucket, it has the data for airlines, it has the data for airports, the routes and everything. It will go and query the data to find out for the airport, San Francisco to the destination, Seattle, for start date and end date, what are the available flights, right? So you see the results. So we have a bunch of results came up, right? Now if you go back to the index, you'll see a bunch of activities here on the query node, on the index node. So for example, if I see the query node, you'll see there was some activity on the nickel queries, right? So what I was trying to show here is like when you do any operation on each of these workloads, those doesn't affect the other workloads, right? So your core data, which is doing the business, most of the core operations don't get affected, right? So you have all your sub-millisecond response time, your throughput are still not affected. You now run a bunch of complex queries on your data on the query node, which is powerful because you have scaled it differently. You have much more powerful machine. It can take the load. In the sense, it can do much more. It can run much faster without affecting your core data or without affecting your index data. Any questions on the demo? Yes.
Is it possible for you to demonstrate how you speed up the query performance by adding or scaling it up? In the last query, I saw that it took 30 seconds or something.
Good question. Actually, there's one big session happening after, right? I think in the afternoon, which Jihan is going to present. He's going to talk about how to tune your performance for queries. The idea behind running the performance is like even small changes. For example, when you add a particular index for a particular attribute, can speed up the whole processing, right? So he's going to go in deep and to talk about how to tune your performance for the queries. I would encourage you to attend that session. So monitoring stats wise, I want to quickly show you one more thing here before I switch back. So a bunch of new stats have been added. For example, if you go and click on travel sample, right? So a bunch of new stats have been added for, like say, we have created a primary indexes, and we saw that we have created index, and you'll see a bunch of stats appearing on our monitoring stats, right? So for each of these services, we have added, like the data service was there before, for the query service, for index service, now we have a bunch of new stats. So we can monitor them and see what's happening with those services. Yes?
Your local Couchbase Server.
Yes.
And it is data node. Is
Okay.
it possible to add index and query to same node?
The same node? So yes, you can do that. Not.
I tried yesterday.
No. Okay. So you cannot, once you have set up the node, once you have already initiated the node, you cannot go back and change the same node. You have to do it when you do it for the first time. Right. So that's one of the limitations. So it's basically when you initiate it, let's say we are doing a setup for the first time, right? If I had time, I will show you. But when you do this, when you go through the setup wizard, it will ask you what services you want to enable. At that time, if you enable all of them, it will enable it. But if you have already set up the service for data, you cannot go back and change it now, right? Okay. Yes.
So let's say we have some set of nodes set for the data service,
Okay.
which are like less cores,
Mhm.
and some query nodes are set up like some 60 cores or something like that.
Correct.
So one day, one of the nodes is failed. Then the engineer who is working at
Yeah.
the operations, he has to bring up the node back.
Yep.
As usual, like bring up that
Mhm.
node. But does Couchbase persist the information that earlier used, the configuration, like this node is used for the query service, this node is used for the index service. Does it persist somewhere so that the engineer doesn't have to go through a lot of.
It's a good question. Right now, we do this for the data service. Right, so I showed you when I did a failover of this machine, and when I wanted to bring it back, it asked me whether you want to do a delta node recovery, right? So we bring the server back to the cluster on a delta basis, in the sense like we don't want to start from the scratch, right? If you had a terabyte of data, okay, so you have a terabyte of data, and then you fail over the server. When you want for a maintenance operation or for any reason, and you want to bring back the server, you don't want to start from the beginning, right? So you want to catch up from where you left off. So that is possible with the data service. We do have some configuration about, let's say you remove a server. If I go back here, right? If I, let's say, go back here, and this is the index service. If I do a failover of this machine, right? So basically, it's out. It doesn't give you option to do a delta recovery on this one, right? Because it doesn't persist any data there. But you can bring the same server back to the cluster. It will, that's possible. But if you entirely remove the server, then it lose the context of which server was it, what was the IP address, then it will be a new server for us. Okay, I think pretty much I will close on my presentation. So just to recap, I talked about multidimensional scalability, why it's awesome. It's the best part of the multidimensional scalability is isolating the workload, separating them up, and also scaling them independently and scaling them with a different scalability model, right? So that's the awesome about the MDS, right? And also I show you a live demo of like when you add more nodes or for the data service or query service, it won't impact the other workloads, right? I think thank you so much for joining my presentation. Thank you.